Hello everyone, and thank you for joining me. So in this video, I'd like to cover a couple of things. Number one, I'd like to cover how the default route is announced into this multi-area OSPF domain and how the different areas interpret that default route. And most importantly, I'd also like to convert area 1 into a stub. And I want to redefine this area as a stub. And I'd also like to study its behavior as a result of it being defined as a stub. But before we do that, I just want to go over really quickly what we've learned so far because I think it's really important, okay? So number one, recap. LSA type 1 packets are intra-area routes. They are seen as O in the routing table, okay? LSA type 2 packets only exist when there's a designated router and backup designated router present, normally in a broadcast network environment, which is something we currently do not have in this multi-area OSPF design that we've created together. Number two, we learned that LSA type 3 routes are generated by the area border router. Okay, because the area border router has interfaces that pertain to area 0 and pertain to area 1, he is eligible to receive these LSA type packets. But in addition to receiving these LSA type packets, he does flood the LSAs that pertain to area 0 and flood the LSA 1 type packets that pertain to area 1 into their counterparty area. And as a result, they're identified as O in the routing table, but they're inter-area routes. They are routes that belong in another area, but that are being announced by an area border router. Okay? Perfect. Thirdly, we learned that to make OSPF more efficient and scalable, we need to reduce the OSPF database table. Okay? We need a way to reduce the OSPF database table. And the way we do that is by, number one, creating multiple areas, which are sub-routing domains, okay, in OSPF, which is a design consideration when your primary single AS exceeds 50 routers, right? It's time to consider creating multiple areas to reduce the OSPF database table. Okay, but in addition and in companionship to that, the most effective way is to introduce summarization. Okay, now in the previous video, when I announced these 4/24s from this particular area 1 border router, we saw that Acme Edge 1 was receiving each and every single /24. This can become cumbersome as the network expands. As you can see, I have room to expand my access layer IP address space to this many IPs, which is a lot, right? So the best way to do that is to go on the area border router and to summarize and basically say that all these networks are represented by this /20. And we do that, okay, by going into the router and typing in this particular command. And as you can see, I've done it for these two ranges that pertain to area 1. All right, so basically what it's saying is that area 1 range 172.16.32.0, okay, this command identifies area 1 as the area that contains the range of networks that need to be summarized, okay? Now, another very important point that I like to make is that if I do a show IP route, all right, sorry, I'm on the core 1. Let me just go to this router here. If I do a show IP route, what we also learned, which is very important, is that intra-area routes will always be preferred over inter-area routes, okay? We also learned that the cost of the inter-area routes is always the cost to that particular destination plus the cost it takes to get to the ABR. So there is a little bit of an understanding with this cost value here, okay? Now, having said that, I'd like to continue with the default route and the stub area. All right, enjoy. All right, so let's go ahead and cover how to announce the default route in OSPF and review how the default route is interpreted by our multi-area OSPF implementation. Now to do this, I have to go on to our autonomous system border router, which is Acme Edge 1. Acme Edge 1 is the autonomous system border router. It is the edge of our multi-area OSPF network that allows traffic to exit out of this routing domain. So to do that, I have to do two things. I have to go on to Acme Edge 1 and I go config T and I add the static route that's pointing to the internet. Secondly, I go under router OSPF 1 and I enter in the command default information originate always. Okay, these two commands, what it does is it allows the ASBR, the Autonomous System Border Router, to originate an LSA type 5 packet. So now we're talking about LSA type 5 packets, all right, or updates in OSPF. The LSA type 5 update is an update that contains external networks. So prefixes like the default route, for example, do not reside or originate within our multi-area OSPF autonomous system. They are external. So therefore, only the ASBR can announce these LSA type 5 updates. Now, once these LSA type 5 updates arrive at the ABR, which is the Autonomous System Border Router, the Autonomous System Border Router should regenerate these LSA type 5 updates downstream into Area 1 and Area 2 in accordance. So let's go and have a look. So if I go to my Area 1 router and I do show IP route OSPF, I can see that I am receiving the default route with an administrative distance of 110 for OSPF. It is tagged as an external route 2 as opposed to external route 1, and we'll talk about that. But pay close attention to the cost. See how the cost is 1? So area 1, router 1 sees this external route as a cost of 1. If I go to Area 2, IP route OSPF, we see the exact same thing. It's considered an external type 2 route with a cost of 1 and administrative distance of 110. What's interesting is if I do it here, I also see the exact same criteria. I see that it's an external route with administrative 110 and a cost of 1, right? Now, you're probably saying, well, why is the cost of 1 being preserved as it's being announced from the ASBR downstream and being regenerated by the ABR? Well, the reason for that, because it's being considered as an E2 route. You see, the difference between an E1 route and an E2 route are the following. Now, an E1 route will always add the cost to reach the ASBR to the external cost. So this external cost is 1, right? If this was an E1 route, right, the cost would be the external route plus the accumulated costs to reach the ASBR. But since this default route was announced as an LSA type 5 E2 route, the external route cost is preserved in the update throughout the multi-area OSPF domain. And that is why Acme Core 1 and the Area 1 border router have the exact same costs. Okay? Now, let's take a look at the OSPF database, for example, because I'd like to talk about that for just a moment. So if I do show IP OSPF database, we see something interesting. Because the ABR, when it generated the LSA type 5 downstream into Area 1, it also accompanied it with an LSA type 4 packet. Now why? What is an LSA type 4 update? An LSA type 4 update is generated in companionship to the LSA type 5, right, by the ABR, because the routers in Area 1 need to know how that route, that external route, was or originated. Okay, so remember, the ASBR does not reside in Area 1. It resides in Area 0. So when the LSA Type 5 update is generated by the ASBR and hits the ABR regenerates the LSA Type 5 downstream in companionship with an LSA Type 4 on how to reach the ASBR. So this is very important. Okay, so let's go ahead and move on to our next objective and talk about the different area definitions that we have at our disposal. So up until this point, we've been talking about a backbone area and a standard area. Now the backbone area was when we configured these 4 routers and allowed them to create adjacencies in area 0, which is considered the backbone area in OSPF. Okay, now area 1 and area 2, which is a little bit off screen here, so this is area 1 and area 2, these areas here are considered standard areas. And the reason why they're considered standard areas is because the LSAs that flow between area 0 and area 1 are not blocked. They're able to flow freely between the two areas. And this is the standard behavior of a standard area. However, in OSPF, we have the ability to define other different areas. So as we see here, we have the backbone area, which we've defined, the standard area, which is area 1 and 2, and there are two additional organic areas in OSPF, the stub area and the not so stubby area. These 4 area definitions are not Cisco proprietary, okay? There is also the totally stubby area and the totally stubby, not so stubby area that are Cisco proprietary, okay? Now, the first 2 we've covered in detail, but I'd like to go over and configure area 1 as a stub and see what happens. So to do that, we have to go on every single router in this area who is participating in area 1, and under the router OSPF1 process, I have to type area 1 stub, and this will create the OSPF process to reform the adjacencies all over again. So why don't we go ahead and try doing that. So I'm going to go on core 1, I'm going to go config T, router OSPF1, and I'm going to go area 1 stub. And we see, there you go. Config T, router OSPF1, area 1 stub. Config T, router OSPF1, area 1 stub. Config T, router OSPF1, area 1 stub. Now, there you go. I'm just going to clear IP OSPF process. Just do a nice clear. Okay, let that sit for a second, and then we're going to take a look at what's happened here. So let's go take a look at the show IP OSPF database, for example, and see what kind of action is going on in there. So in effect, we do see that there is a change. Okay, so what we're seeing here is that the LSA type 5s do not exist anymore. What we're witnessing is we're seeing LSA type 3s only being generated by the area border router. So what we're seeing is that the ABR is blocking the LSA type 5s and no longer regenerating the LSA type 5s into the area, but rather consistently advertising the LSA type 3 type routes. So let's just take a look at the routing table and see how this works. So if I do a show IP route to OSPF, effectively what we saw in the database table is actually what we're seeing in the routing table. So what's happening is that the LSA type 5 is coming, it's arriving on the ABR. The ABR is not allowing that LSA type 5 to be regenerated into area 1, but rather what the ABR is doing is substituting the LSA type 5, which is the default route that's being advertised with ASBR, substituting it with a locally defined default route, and announcing that out as a LSA type 5. So what we can confirm is that in a stub area, right, external routes are not allowed. Okay, the only type of routes that are allowed into a stub area are the inter-area routes that the ABR is announcing into the area, which is quite interesting. So I think we're at a good point to kind of just sit back and kind of reassess what we've learned up to this point, because the reason why we create multi-area OSPF design considerations, or we perform summarization on the ABR, or try to mitigate the way LSAs or flow into one area or out into another area, or define the areas as stub area and not so stubby area, is because it plays more of a bigger theme, right? And the whole idea is to reduce the SPF calculations, to reduce the conversions time, to make the OSPF database table as small as possible, which effectively will have a big impact on the effectiveness of OSPF and its convergence time. It'll make it run a lot better. And this is the reason why we're learning this stuff today. Okay. Now that is from the logical perspective, but from the physical perspective, like the hardware perspective, it has an enormous amount of significance in terms of memory and processor and hardware as well. So if we can mitigate, or if we can contain, or if we can find the ability to manage the OSPF database table, we're fine-tuning our network, our routing domain, to operate in a more effective manner, okay, which I think is extremely important.